Please welcome Autodesk Vice President of Design and Manufacturing Business Strategy, Gregg Fowler.
We're living in a time of dramatic change. Products are getting smarter, and the machines that make them are getting even smarter. There's no doubt that tremendous need remains in the world. But we live in a time where quality of life is increasing faster than ever in history before. 2 years from now, half of the world's population will be considered middle class. That's 3.5 billion people buying cars, furniture, packaged food, phones, computers, and on and on. In 2010, there were 250,000 new product introductions. This year, there will have been over 370,000. The number is increasing year after year. But there's a problem. Manufacturing productivity is growing slower than the pace of change. Manufacturers who design and produce those products are having a hard time keeping up with increasing demands. Productivity growth in manufacturing has just been 3% over 10 years. 70%. That's the amount of manufacturing cost that is determined early in the product development cycle. We've known since people started making things that thinking about how things are made while you're designing them makes it easier to make them. One look at this image, and we all know why. Every manufacturing method has its own set of requirements. For this mill, every shaving of metal costs money. Every curve, every angle slows the process down. New means of production have amazing benefits. The ability to vary materials so that products can be stiff in some areas and flexible in others. The ability to create shapes that are nearly impossible to manufacture with traditional methods. With additive manufacturing, complexity is free. But even with these new, flexible production methods, the way that you design your product significantly impacts how it can be manufactured. And they do it in very different, sometimes contradictory ways. In the world of additive manufacturing, the less material you use, the more holes, the more gaps, the cheaper your design is to manufacture. It's the opposite from what you'd expect with a CNC machine. It's complicated. To make it more challenging, as a designer, you're not always sure which manufacturing machines and methods are going to be used by your suppliers. Sometimes, you don't even know what machines and methods will be used in your own factories. But we're in a digital world now, right? Designers can easily collaborate with manufacturing engineers. Sort of. Even in the best case scenario, when you know exactly who you need to work with to make sure that the design is optimized for manufacturability, you face the difficulty of sharing information. With collaborators working in multiple data formats, this is often the outcome. And once you get the design data to your collaborators in a way that they can use it, there's another hurdle. These are the most commonly used tools for collaboration. They're effective, but time-consuming to use, difficult to track, and hard to record. 1/3. That's the amount of time an average design engineer wastes on non-value-added tasks, like dealing with incompatible file formats, transcribing notes, recording comments into PLM systems, and on and on. While our time as engineers is taken up fighting with file formats, trying to decipher our colleagues' handwriting, and retyping comments into PLM so that they can be archived, the very products we design are getting more complex. Designing them requires more of our time, more of our expertise. Electronics, sensors, and new materials are present in almost every new machine designed. And even though designs are getting more complex and new product releases are increasing, we still need to make sure that they work safely and meet the quality expectations of their users, your customers. While we are busy making newer, more complex products with new materials and new technologies, using newer, sometimes more complex manufacturing processes at a quality that both keeps customers safe and delights them, we have this other new trend looming. Customers more and more are expecting products to meet their specific needs. Take a look at this picture. It's no joke. Virtually every Mini that comes out of the factory is unique. And your competition isn't standing still. And competition for your products may not even be coming from the same place it always has. Companies have to worry about new disruptive technologies that are often a bigger threat than traditional competitors. It's no wonder then, with a pressure to do more with less time, at lower costs, with multiple disconnects between people, data, and processes, that we sometimes end up in trouble. Trouble with delays, cost overruns, or worse. Problems for your customers, problems for your companies. Yesterday, you heard Andrew talking about the future of making and the need to do better. For the manufacturing industry, the future is about making our products better. It's about making our work better. It's about making our lives better. But faced with all the roadblocks in collaborating, hurdles in sharing data, and pressures to do more with less, how can we possibly do better? To deliver that future, we need to be more connected. We need to break down silos. We need to bring design and manufacturing closer together. Connecting data, people, and processes is the key to digital transformation. This is the convergence of design and manufacturing. It's the future of making. And it all starts with data at the center. When you put data at the center of your processes and connect it to the right people at the right time, you break down the silos in the design process. Putting data at the center enables the connection of tools, processes, and people. And once the people and processes are connected, you can automate the processes themselves. Generative design, for example, automates the ideation process, giving the user the ability to easily explore all valid geometric options for a given set of materials, manufacturing processes, and operating conditions. And because you ultimately need to get a physical product in the hands of your customers, we're making it possible to connect into your manufacturing facilities, even if that extends across the boundaries of your organization into your supply chain. In a few moments, you're going to hear from my colleague, Kelly Dumont, about how the product design and manufacturing collection makes it easier to share data between tools, people, and processes, and how it connects design to production. After Kelly, you'll hear from Thomas Naugle about how Claudius Peters is digitizing and transforming their design and manufacturing processes. You'll then hear from my colleague Stephen Hooper about how generative design and automation are transforming the design-to-make process and what you can expect from us in the coming years. Please welcome to the stage Kelly Dumont. Hey, Kelly.
Thank you. Thanks, Greg. Gregg painted a vivid picture of the need for connecting teams and business processes across your companies. And I'm going to show you in more detail how these connections are enabled, not just by the product design and manufacturing collection, but by the expertise of your Autodesk global account teams worldwide. There are so many tools within the collection that will be critical to efficiency and smooth design and manufacturing. So I'd like to start by highlighting some new technology inside of Inventor, and then expand to show the full power of the design and manufacturing collection. Many of you have experienced life as mechanical engineers, designers, and production engineers. We know that user experience is the deciding factor between a product that's going to be central to you and a product that's never going to see work in your business process. With an eye to that user experience, we've made a raft of improvements to Inventor over the past year, 243 of them to be precise. These improvements aid your productivity and usability at every stage of the design and manufacturing experience. And we at Autodesk put your experience before anything else. It's our value, and it's what drives us as a company. So whether it's improved factory utilities for our process customers, powerful simulation tools, or the ability to easily share data across your global teams, Inventor and the collections will become your go-to tools. Let's take a look at a couple of specific Inventor examples designed to promote efficiency. The improvements we've made to the whole function that you see behind me streamline your workflow by reducing clicks, mouse movement, and context switching, making it a lot easier for you to get the job done. Another really exciting feature within Inventor is tolerance analysis. It provides an in-canvas workflow to include imagery, tolerance objectives, and a list of contributors and percentages for the stack-up. You can communicate results quickly, and this is a huge time saver and will help to ensure that your design meets your manufacturing requirements. As you've seen, Inventor is a very powerful tool. It's one that we're committed to and one that we're investing in. With thousands of improvements over the course of several years, we've focused on enabling professional design automation with advanced simulation capability, integrated manufacturing workflows, and much more. So it's my great pleasure to introduce you to the best Inventor ever. Now, we've talked a lot about Inventor, but the product design and manufacturing collection is about cross-functional business workflows that support global needs. While focusing on project features and capabilities, we've also made it easier for you to leverage the power of our product portfolio and gain access to the value that we're delivering through subscription. You've heard us talk about the future of making for the manufacturing industry. It's with the collection that Autodesk is bringing together the tools necessary to centralize product data, unite teams for better collaboration, and ultimately automate processes across disciplines. To begin the journey into the future of making, the collection helps to bring together teams within engineering. You not only have the ability to create 3D design, but also the tools needed to validate that design and accurately document it in 2D. Knowing the power of simulation within the design process, we've added Nastran simulation solvers to this mix. Customers that I've worked with personally have seen the value of this simulation in rapid prototyping. With several $100,000 of savings per prototype, the ability to simulate during design has reduced weeks of time and hundreds of thousands of dollars in that customer's pursuit of new product introduction. This means that you can adapt to change faster, with less risk, and make upfront decisions quickly with better data and better insight. And this changes design for you in two really important ways. First, you can look at permanent deformation like vibration, contact, and buckling to understand what happens if a design fails. And second, you can look at the impact of multiple forces over a period of time, like when you snap two plastic components together in an assembly. And we all now have access to that same technology directly from within Inventor. And because your validated 3D design requires accurate 2D documentation, you not only have Inventor, but you've also got AutoCAD. two powerhouse products together in the same package. We know it's rare to see a purely 3D environment today. Most of us work in that mixed environment that I just talked about. And the collection brings together the best of both worlds. Streamlined 3D modeling and 2D design, all available to your design teams in one single accessible place. Even if you are designing entirely in 3D with Inventor, your validated 3D design probably requires accurate 2D documentation. You may even need to reverse that workflow. Whether you've got a 2D drawing from a client or you want to update an older design to 3D, you can import your 2D drawings as the starting point for your 3D model. And because of the associativity between Inventor and AutoCAD, any changes to your 2D drawing will be automatically reflected in your new 3D model. It's powerful. But as we all know, it's not just about design. Your teams won't be successful if they can't make what your engineering teams have spent hours designing. So the collection connects design and manufacturing capabilities. So not only do you have the tools to create highly differentiated product designs, but all the CAM capabilities required to turn those concepts into physical reality with fully integrated 2.5 to 5-axis CAM. And you now have the power to produce G-code directly from within Inventor. Ultimately, we're all paid to produce the physical output of that creativity. And the CAM capabilities directly integrated within Inventor help you to do just that. But it doesn't stop at just CAM. We've also updated the collection to include sheet metal nesting. Inventor's nesting utility will take that data and optimize the sheet layout so that we can ensure maximum utilization from raw material and maximum efficiency from our shop tools. We've covered design, we've covered manufacturing. Let's take a look at another downstream process. It's critical for your teams to stay connected 24/7 to your global supply chain. That's why we're developing tools both in the collection and on the cloud to help you share and access that information that your extended organization needs for collaboration, quoting, and supplier management. So how do we create those 24/7 connections we just talked about? Vault is one way. The powerful data management tool makes it possible to share data, maintain accurate bill of materials, and keep the extended team always working from the most updated product definition. And with Fusion 360 now in the collection, you have access to easy-to-use collaboration tools for viewing and markup when reviewing designs with your suppliers. Now, we all know that your job doesn't stop when your product design is finished. Many of you in this audience are making equipment that support factories or products that are integrated into buildings. Industrialized construction, the need to integrate that equipment design with the space it will ultimately occupy. With the product design and manufacturing collection, we're helping you to make that connection to ensure that there are no surprises when you reach the installation and inspection phases of your project. Because an error in that phase of the project can cost hundreds of thousands of dollars and result in days of downtime for a factory. We've helped to eliminate the guesswork and ensure reliable outcomes with our collection tools. Manufacturers of everything from HVAC systems to windows to elevators typically use mechanical 3D CAD software to create high-fidelity models that are needed to ensure proper manufacturing and assembly. But architecture, engineering, and construction firms use a different standard, building information modeling, BIM, to manage, design, construct building projects. Autodesk makes it easy to share between those two platforms, Inventor and Revit. So whether you're on the manufacturing side of that equation or on the construction side, you now have solid workflows that will ensure traceability and accuracy through the entire life cycle of your project. We're also making it easy for manufacturers to understand how their machine will perform in a factory setting. If you haven't tried them yet, I really encourage you to try out the powerful factory design utilities available only in the collection. This tool set makes it easy to plan and validate factory layouts for efficient equipment placement to improve production performance. Another key benefit of connecting product data across an organization is that it unlocks the potential for automation. Automation capabilities are already available to you today in the collection, including iLogic and Inventor, and including Generative Design in Fusion 360. And the real power of automation is unlocked when you put the design in the hands of your customer, but in such a way that you guarantee manufacturability. We've seen consumer products companies cut 20% of the time required to fulfill a semi-custom design, all using the tools that are provided in the collection. iLogic is an incredible design automation tool that will be of particular interest to you in the audience who are designing configurable products. Sales configurators can significantly accelerate the time from initial design to final delivery. Remember that 20% time savings that I was just referring to? But while ensuring that your products meet manufacturing requirements, which is critical. The connections that we're making possible with the product design and manufacturing collection are having a real and tangible impact on the businesses that I work with every day. Whether it's rapid prototyping through simulation, design automation that ensures manufacturability, or the power of industrialized design connecting manufacturing and construction, the collection holds great promise for a wide variety of you in the audience today. So as Scott Burdine yesterday referenced in our AU keynote, you looked at Jet Propulsion Labs designing a product for lunar exploration to determine whether there's life on another planet. But the future of making for manufacturing isn't about outer space. It's not just aeronautics companies and automotive companies who are utilizing this technology. It's real manufacturing companies that we're working with every day. So today, I have the great pleasure to introduce you to our next guest from Claudius Peters, a 100-year-old equipment manufacturer serving the cement industry. I mean, let's get real. It doesn't get more down to earth than cement. So here to show us how very traditional manufacturing companies can embrace the future, please welcome Thomas Naugle, Chief Digital Officer of Claudius Peters. Thank you, Thomas.
Thank you, Kelly. I'm very excited to tell our story here at Autodesk University. Claudius Peters was founded in 1906 and is now headquartered in Buxtehude near Hamburg in Germany. We are serving a very heavy-duty industry. We at Claudius Peters have the saying, the workers at a steel plant are switching off the light with a hammer. Today, Claudius Peters is a leading manufacturer of materials handling and processing equipment that can be found in cement, gypsum, power, aluminium, and steel plants across the globe. In our 100 years, we have grown to an international company with a dozen offices worldwide. But 100 years also means that we are a dinosaur. How does a dinosaur avoid extinction? In a word, innovation. Going into the 21st century, we made a very intentional decision to go from good to great. To become an excellent and modern company of the future, we started our innovation journey, Inspired Excellence. Increasing customer satisfaction, delivering higher quality, while reducing lead times and costs are our 4 goals. We learned that the digital transformation is not a project, but an inner attitude. The questions of today and tomorrow will not be answered and solved by the knowledge and experience of yesterday. So it is also my job to transform Claudius Peters into an agile company. This means to develop new digital skills and a new culture at Claudius Peters. This requires more than modern software. It requires a great internal team, a good network, and strong partners. With the vision of the future of making things, Autodesk is the perfect partner for us. This vision and their solution put an agile product and project management and development in the center of the work. And it connects processes from sales to engineering, or design to manufacturing, or engineering to assembly. Our new ETA cooler embodies best the spirit of innovation and cooperation with Autodesk. The ETA cooler is a massive machine that cools down fluid stone, so you can say lava, down to 90 degrees. The machines have dimensions like 50 times 25 meters. For American, that's about half of a football field. An interdisciplinary team at Claudius developed with Inventor and FEM an intelligent way to manufacture our cooler lanes within a few hours instead of days before. We no longer have to machine our lanes, but achieve quality by joining and welding them together. And it also meant that we were able to bring back the production to Germany, to our facilities. As many of you know, cement is a great product. But the production of cement requires a lot of energy and produces greenhouse gas. One of the greatest benefits of our ETA cooler is the outstanding thermal efficiency. These energy savings of our machine can help to reduce the negative environmental impact on the cement production. We design our machines with Inventor and AutoCAD Mechanical, as Kelly talked about. With intelligent iLogic and parametric assets, we are placing our equipment and machines with factory design utilities in our plants or factories. Early this year, we learned more about scanning using Recap Pro, Navisworks, and BIM 360. So we started to use the modern and efficient collaboration tools from Autodesk. After 2 weeks test with BIM 360, I asked my team, how does the test go? Are you testing at all? I do not hear anything. The answer was, please do not take BIM 360 from us away. We have already 25 colleagues online working on 11 real jobs and projects during the test. I do not know if this was allowed, but today we have 100 people online working on more than 80 projects. For brownfield clinker cooler modification, we travel to China, for example. We scan the existing equipment. We hand over the big files in BIM 360. And we start the engineering and design work with Inventor the next morning in Buxtehude in the headquarter office. This means we do our job faster, with higher quality, at lower costs, and leading to higher customer satisfaction. These solutions are just great, because you start using them after days, not weeks or months or even years. But our innovation didn't stop there. Last year, at my first AU in Vegas, I got inspired by the emerging Autodesk technology, Generative Design in Fusion 360. We believe in the spirit. The electric light was not an improvement of the candle. This means for us, we have to do things completely different than before to make a real change. So we started a test with generative design without having a real plan or a clear goal. We took apart which was just optimized by our design department. After a 4-hour training from Autodesk, we had our first result. We called it the alien part. The result surprised us. How can the alien part be so different from our optimized part and 25% lighter? But what shall we do with an organic 3D part? In our industry, we need parts which can be produced and manufactured with traditional methods. One day later, our mastermind, Pascal, decided to start a reverse engineering with Inventor and FEM analysis based on the generative design part from Fusion 360. To be perfectly honest, our design engineer on that project was sure that generative design would simply not work. But to his credit, he was willing to give it a try anyway. FEM analysis of the overall context surprised us. The generative design part behaved even better without tension peaks. Since our first generative study a few months ago, we tested, as you see, different solutions. Very important in this process was that we involved the foundry and our workshop at a very early stage. We decided that we move now from a casting to a laser cut plates and welding solution. We made the part 25% lighter, simpler, faster available, and more cost efficient. Last year in Vegas, I was impressed, inspired, and also shocked to see the possibilities with the Autodesk solutions. With a great team at Claudius Peters and with Autodesk as a strong partner on our side, we achieved in just 1 year remarkable results and improvements on our innovation journey. We are convinced if we continue our journey with partners like Autodesk, we will avoid extinction and/or disruption, and we will stay competitive in the market. I encourage you to continue your journeys. Be brave, be inspired, be open-minded, try and experiment crazy-looking ideas and tools. Here, I would like to introduce Stephen Hooper to tell us more about Fusion 360 and generative design.
Outstanding. How do you follow that? Thomas, you're amazing, seriously. So I really do want to thank you as well for taking the time to come out here and speak to everyone. It was a fantastic presentation. I know everyone enjoys listening to a customer. So, Thomas described a compelling workflow that illustrates the convergence of design and manufacturing. He highlighted why you can't separate the principles of design from the manufacturing processes employed to realize those ideas in physical reality. He also demonstrated that it's not just additive manufacturing techniques that can influence how we design. As machine tool manufacturers like ours start to democratize access to NC-controlled manufacturing equipment, the opportunity for everyone to employ automation techniques increases. So to illustrate this opportunity, I'd like to introduce you to Will. Will design and manufacture personal electric vehicles that aid people with physical impairments. They're a collection customer, but they work extensively with Fusion 360. Their product is unique in that it combines style, technology, and freedom. It empowers the individual to reclaim their love of the outdoors. Now, the people behind this fascinating product are separated by two of the planet's largest oceans, and yet they act as a single, unified team. They have facilities in California, Japan, and the UK. They collaborate extensively between these locations and address all elements of the product development process. This is the ultimate goal of Fusion 360 and the Product Design and Manufacturing Collection, to focus on the people behind the product development process rather than the individual tasks that they perform. As you know, product development is a process, not a task, yet we talk in terms of CAD, CAM, CFD, surfacing, or FEA, and we often forget the most important thing, the person at the center of this process. Product development begins with a conceptual definition, but it includes physical prototyping, mechanical design, electrical design, purchasing, procurement, and a raft of manufacturing processes from robotics for picking and placing electronics to additive and subtractive manufacturing through to the final assembly. Our goal has been to develop a single product that serves the needs of this entire process and the professionals who perform it, not a point-based solution. That's why we built Fusion 360. But Fusion 360 is also included in the Product Design and Manufacturing Collection, and as such, it works seamlessly with Inventor. Take Will, for example. Their California office works with Inventor, but their UK and Japanese offices use Fusion 360 for styling and manufacturing. All three offices work together by using AnyCAD to associatively exchange data. That means that anyone, anywhere in the world, has got access to the same source of information that allows them to redline, markup, and collaborate. So the Californian office can offer advice to the UK on how to style the wheel guards, or instruct the Japanese team on the test and build of the base plate for the seat. And because Fusion 360 includes all of the tools for the product development process, the UK team can use it for styling and maintain that design intent as they take the process through to detail engineering and fully model that component. They can also document all of this information directly inside of the same environment and share that information via the cloud. The folks back in Japan also have access to tools like nonlinear simulation for assembly, so they can test the functional performance of the base plate for the seat. And then they can move seamlessly into an integrated manufacturing environment that allows them to create a number of different setups, from drilling operations through to 2.5-axis machining to full 5-axis subtractive manufacture. And they can do all of that on a Mac, on a mobile, and on a PC. So when you ask yourself the question, is Fusion 360 a CAD system? Is it a data management tool? Is it a simulation technology or a CAM program? I hope you can see that the answer to all those questions is no. It's not one of those things. It's a complete product development platform that connects the entire process from concept definition through to the manufactured product. In doing so, it establishes a digital pipeline for design and manufacture. And once you've established a digital pipeline, you can turn your attention to automation. And that's where things start to get really interesting. You'll remember I mentioned earlier that Will's personal mobility product separates into 3 modules for ease of transportation. Well, those modules, they need to meet some customer requirements. Most importantly, they need to be light enough for the average person to move them into the trunk of a car with ease. So market research tells Will that the weight that they need to design for is around about 15 kilograms. Now, this is where you can use the power of generative design to automate the process of defining an innovative solution. So at first pass, the problem might seem easy. Just redesign the part to be less than 15 kilograms. You might ask yourself, why wouldn't you use topology optimization to solve the challenge? But think about it for a moment, and you'll realize that it's infinitely more complex than you'd first assumed. There are many different choices that a designer needs to make in their quest to develop a product that's both innovative and performant. They first need to select materials. They need to ensure that the materials that they're selecting are strong enough, light enough, and cheap enough to meet the customer requirements. But they're not done there. Next, they have to think about the loads the part will be under through all phases of its operation. They need to understand the areas of the design that they'll need to avoid, those marked in red. And they also need to think about areas of geometry they need to preserve to ensure assembly tolerances are maintained, those marked in green. Finally, there are constraints imposed by the manufacturing processes they have access to. Do they have a Haas machining center, a plasma cutter, or a 3D printer? Each type of manufacturing process has various different benefits and drawbacks, ranging from cost and performance to quality and aesthetics. As a good engineer, we'll develop an initial concept. And based upon the time constraints imposed on us, we'll iterate across a number of variants. The problem is that as human beings, there's a natural limit to how many of these alternatives you can explore, and a time in which you have the luxury to do so. But given the range of parameters and variables that we just discussed, there aren't just 5 or 6 answers. There are literally thousands of potential designs that meet the criteria we just outlined, each with a unique set of benefits, trade-offs, and constraints. And that is where a digital pipeline combined with the power of the cloud comes into play, and where automation in the form of generative design can give you a competitive advantage unlike anything before. So let's take a look at this technology in action on the rear upright. Directly from within Fusion 360, we can activate the generative design environment. From this environment, we can define preserves marked in green. We can also start to dynamically define keep-out zones, areas we want to avoid. Then we can specify the target goal of the study, a factor of safety of 3. Most importantly, we can start to specify our manufacturing constraints, whether it's 3-axis subtractive manufacture or 5-axis, or maybe a combination of both with additive. Next, we see a preview of the types of results we can expect before we push this study to the cloud, where we get not one right answer, but thousands of right alternatives that we can use tools to browse and evaluate the trade-offs between the various different types of material or manufacturing constraint. And once we've selected the alternative that we'd like to work with, we can download that, not as a piece of mesh geometry, but as a first-class native piece of CAD geometry. And what that means is you can continue to use all those styling tools inside of Fusion to improve the aesthetics of the design that you produce. You can use T-splines to remove some of those openings, thicken up some of the struts, soft select tools that allow you to globally modify the whole mesh. You can also revalidate the design with integrated nonlinear FEA studies, but most importantly, you can move to a fully integrated hybrid manufacturing environment for additive-based metal combined with full 5-axis subtractive machining. I'm going to show you a sneak peek here. We're even starting to integrate some of our metrology technology directly from Power Inspect straight inside of Fusion. What it gives you is an incredibly powerful piece of technology like nothing you've ever seen before, that takes you all the way from initial concept design with generative design straight through to the final manufactured product. So that's pretty cool, but we're not stopping there. We're working on expanding the tool set of manufacturing constraints we include with Fusion 360. We're researching manufacturing constraints that will enable engineers to specify processes such as fabricated structures, 2D profile cut plate, sheet metal, and even 2.5-axis subtractive machining. In doing so, we're radically opening up the applicability of generative design to everyone in this room. So next, what I want to do is I want to show you a couple of pieces of research that we're currently working on. We even got this patented last Thursday just so we could share it here with you at Autodesk University. One great example is the application of generative design to beams and frames. In this simple example, we'll look at the rear support. Again, we can specify preserves and red keep-out geometry, and then you can see that generative design algorithms apply a beam solver to create a structural definition. Now, of course, there are many ways you could manufacture this, so we provide you with the raw geometry, and the choice is yours as the engineer to choose whether you're going to fabricate this from hollow section steel and weld it, or whether you're going to use a more freeform structure, perhaps a carbon fiber layup or an injection mold from polymers. Ultimately, the choice is yours as the design and manufacturing professional to make that choice. In this next example, we'll look at the lower left wheel support. We'll evaluate a human-designed parametric version on the left with two generative alternatives on the right. Now, the parametric version takes longer to produce, and it has unnecessary factors of safety, and that makes it heavier than it needs to be. The question is, how much weight will be reduced by the generative versions? As you can see, the 3-axis version reduces the weight by an extra 18 grams. Now, the question is it worth the extra manufacturing time? The 2.5-axis version completes in just 35 minutes. The human-designed equivalent takes nearly an hour, but the 3-axis version takes even longer, 4 times longer than the 2.5-axis version. Now, if this was an aerospace component, that might be okay, but considering the manufacturing costs, it's probably not worth saving the extra 18 grams in this case. In the end, it's all about trade-off decisions. Trade-off decisions that balance market requirements with product capabilities, cost, quality, and manufacturing time to market. That's why you, as the designer, do best, and that is the reason that we built generative design to help you. But the real kicker is that the generative version took the machine just 20 minutes to define, as opposed to the human-designed equivalent that took 3.5 hours to fully validate. Now, you remember earlier I said about design exploration. I talked about the need for innovation. Well, the human only had time to evaluate 3 alternatives as part of that manual process. You can see the 2 generative examples were able to return over 100 different variants from which you, as the designer, could select the most appropriate trade-off. And it's that type of capability that will provide you with the ultimate innovation in time to market. The possibilities are endless. With the power of generative design, an engineer can stipulate the manufacturing process, define the design requirements and materials, leveraging the power of the cloud to explore near limitless potential solutions, all with hybrid manufacturing. And most importantly, this technology is available to everyone in this room, and it works with any CAD. So take, for example, the upright for the EPV that we just developed with generative design. On the left of the screen, you can see Inventor, and on the right, you see Fusion 360. Now, we're able to take that generatively designed component and associatively insert it directly into Inventor. That means if we go back to Fusion and we start to use those T-spline tools to modify and manipulate the design, style it further, any change that we make will be saved back to the cloud and automatically replicated and updated associatively back inside of Inventor. So now you have a full associative workflow between Fusion's generative design and the power of Inventor that Kelly just shared with you. So as Gregg said earlier, everyone involved in the product design and manufacturing process now has access to the complete set of tools that make up our best Inventor. Design and engineering, advanced simulation, 2.5 to 5-axis CAM, sheet metal nesting. These tools are now complemented by collaboration, hybrid manufacturing, and generative design in Fusion 360, and it's all supported with a bidirectional associative workflow. So if you're a collection owner sat here in the audience, my call to action for you is simple. When you get home, simply navigate to the link that you see on the screen behind me, access your accounts page, and click on the Activate Access button. This will enable you to access your entitlement to Fusion 360. You can simply copy some of your Inventor designs into the Fusion 360 hub, and you can start to experiment with generative design. Like me, as an engineer, I'm sure you'll find it fascinating. As a business, you might soon find it's the key to competitive differentiation, just as Thomas did. So in closing, let me summarize what we've covered today. We discussed the convergence of design and manufacturing and its implications for the product development process. We can no longer think of CAD, CAM, and CAE as separate functions. We explained our commitment to the tools that you use today, Inventor and the collection, and you heard from Thomas and its impact on his business. Finally, we announced the availability of generative design with Fusion 360. So we hope that you found this keynote both informative and entertaining. Remember that there are literally hundreds of classes going on around you. Attend the classes on generative design. There's one starting straight after this break. Network with your peers, and above all, have fun. And hopefully, we'll see all of you here back at Autodesk University next year, when perhaps you can be the next person up on this stage to describe the success that you're having with generative design, Fusion 360, Inventor, and the product design and manufacturing collection. Until then, thank you for being a great audience, and have fun in Vegas.